Bismillahirrahmanirrahim. Calculate V naught in the circuit of figure 1. So this is the figure we are given, and this is the circuit. Uh, so we need to find V naught here across this capacitor. So we will be better off if we transform the circuit into the phasor domain first. So the source here, let's call it V of t in the time domain, is equal to 10 cos 10t plus 75 degrees volts. So let's represent its phasor domain representation as V. So that will be 10 at an angle of 75 degrees volts, right? So omega is, the angular frequency is 10 radians per second. And this 0.5 Henry's inductor, let the corresponding impedance, let's designate it with Z subscript L. That is equal to J omega L is equal to J. Omega is 10 and L is 0.5 hundredths, so that is J 5 ohm. And the impedance of this capacitor, let it be represented by ZC, that is equal to 1 over J omega C, right? And 1 over J is equal to minus J, right? And so that is minus J divided by omega is 10 and C is 1 over 20. So that is basically minus j 20 over 10. So that leaves us with Zc is equal to minus j 2 ohm. And the resistances, they will remain the same. This resistance will remain the same in the phasor domain. Resistance is independent of the frequency omega, so it will remain the same. So we can now redraw the circuit in the time from the time domain and to the phasor domain now. So this is the source. This is 10 angle 75 degrees volts, and we have this parallel combination of an inductor and a resistor here, and this is connected with a capacitor like this. So this is J5 ohm, this inductor, and this is 10 ohm, and this is now minus J2 ohm. And we are interested in voltage V naught. Let it be represented in this phasor domain like this, V naught. So we can find V naught if we transform if we find the equivalent impedance of this parallel combination and then use voltage divider rule to find V naught. So let's call this J5 as Z1. So Z1 is J5 ohm, and let's call this Z2 as let the 10 ohm be denoted by this Z2. So the parallel combination Zp is equal to the equivalent impedance of this parallel combination is Z1 Z2 divided by Z1 plus Z2. So Zp is equal to uh, J5 multiplied by 10 divided by J5 plus 10. So Zp is equal to J50. So this is 50 angle 90 degrees. 1J is equal to 1 angle 90 degrees. So 50 angle 90 degrees, and this 10 plus J5 can also be transformed into the polar form, which will be easier for division. So 10 and this is 5. 10 plus J5. So that is 11.18, and the angle is 26.565 degrees. So ZP is equal to 50 divided by 11.18, that is 4.472, and angle is 90 minus 26.565, that is 63.435 degrees ohms. So this is the impedance of this parallel combination, and this angle is positive here, which means the current through this impedance lags the voltage, which is considering this inductance here. So this is the response of this impedance is also inductive. This is so let's transform this into the rectangular form also. 4.472 at an angle of 63.435. So this is 2 plus J4 ohms. So this has a component of inductive reactance. The component, the imaginary part is inductive reactance, right? So we can now represent this circuit here like this. This is at P, right? And this is in series with now this capacitor here. The voltage across this is V naught, and this is minus J2 ohm. This ZC is equal to minus J2, and this is ZP, and this is V here. So we can now use the voltage divider rule to find this V naught here. So V naught is equal to this ZC divided by ZC plus ZP multiplied by this total voltage here V. So V naught is equal to ZC is minus J2 divided by minus J2 and plus 2 plus J4. So minus J2 is 2 angle minus 90 degrees, because minus J is equal to 1 angle minus 90 degrees. So 2 multiplied by 1 angle minus 90 degrees is equal to 2 angle minus 90 degrees, and divided by that is 2 plus J2. Minus J2 plus J4 is plus J2, and this 2 here. So V naught is equal to 2 angle minus 90 degrees, and we need to multiply this. We don't forget to multiply this with the V here also, right? So this is 2 plus J2. So let's convert this into polar form. 2 plus J2. So that will be 2.828 at an angle of 45 degrees, and plus V here. So V is basically 10 angle 75 degrees. So V naught is equal to 2 divided by 2.828, right? And that is multiplied by 10, and this is equal to 7.072, and the angle is minus 90 plus 75, minus 90 plus 75 minus 45. So that is minus 60 degrees volts. So this is the answer in the phasor domain, but the problem was given in the time domain. So we need to transform this answer into the time domain. So V naught is equal to 7.072, and cos omega is 10 and t, and the phase is minus 60 degrees here, volts. So this is the required answer. So this is the voltage across this capacitor, uh, uh, this capacitor here. And if you note it, this voltage can also be computed in the time domain, but the process will be quite complex.